can make explanations as to why. It's certainly my problem with it is not intuition. It's just like a side point. So you can, it's I could at least hope that the intuition is there. It doesn't need to be there. And yes, you can deflate the intuition. You can have all sorts of ways of deflating the intuition as you've done so now. But anyway, the big problem. So the first issue is that there are certain laws of physics, at least as interpreted by all of physicists, that you probably will also have to actually you will have to reject. So, and the reason you have to reject that is because there are quantities of certain things that have no physical mechanism of traversing infinite cardinalities that the laws of physics actually just straightforwardly entail are going to increase or decrease over time, but they couldn't increase or decrease over time because they have the same cardinality over time if you take this response to work. So, for example, the second law of thermodynamics, as a secular trend, the universe is taken to be a closed system, even on the cosmologists who think the universe is infinite. And all closed systems, the absolute amount of entropy will always increase. Another way of saying it, which also entails that the absolute value of the joules of Gibbs free energy will always decrease throughout as a total value of the universe. And that just can't happen if you take that response to work. Because if the universe is infinite, we could say, well, the total value of Gibbs free energy is infinite. And it can't decrease. It's not possible for it to decrease over time, actually, because the cardinality is the same at right to any time right now to any point in the future. And so,
wait, sorry, I'm not quite getting. Sorry, so are you disputing that the universe is infinite, or are you?
no, I'm saying, yeah, go ahead.
Sorry, yeah, I'm just trying to understand. Are you saying that this means that we should think the universe is not infinite, or are you saying this means that we should think that even conditional on the universe being infinite, that we should still say that things decrease?
Yes. So I'm saying, so actually, it turns out to be that I would say both. I think these sorts of objections are actually going to turn into reasons to think the universe is not infinite. Even among those who think it is infinite in cosmology, they actually acknowledge like these sorts of there are at least some related issues as to what I'm mentioning, and I'm going to get into it. And they would cite this as like not only reasons to think the universe is not infinite, but like the biggest problem with infinite universes, or at least one of the biggest problems. However, even among those cosmologists who would still think the universe is infinite, they don't think that the Gibbs free energy in the universe is not decreasing. They would try all sorts of things. They would probably say something that there's like some sort of misunderstanding about, or like our mathematics is not complete, or something along those lines, or like we just haven't found a solution to the measure problem, not to be confused with the measurement problem, the measure problem. If in terms of expressing it as a ratio of something, but no one would bite the bullet on the infinite fuckiness. So just to be clear on what I am saying, we can get into that, but to be clear on what I am saying, so the main thrust is if you accept this sort of answer as working, if you accept this sort of reasoning as, well, actually, if the universe is infinite, then any absolute rarity is not a rarity at all. Then the problem is that is going to entail a rejection of at least one of.
I am gonna say let's move to not deal with some of these mics.
Okay. Well, create a stage and is there a stage? I don't. Oh, here. Okay, we'll go up. Okay. All right.
Yeah. Okay. So let me okay, so let me address those two things. So regarding the kind of the horn of this, where you suggest that this is a reason to think the universe isn't infinite. So I'll just plead ignorance here. I don't know the physics. For all I know, this could very well be right. But my sense is that, so I just I sort of defer, where it seems like a lot of physicists think that this is at least a reasonably likely possibility. And so I kind of take that seriously. For all, maybe what you're saying is correct. I would just have to look into it more.
That's not the thrust of the issue. That's like the side point of the issue. It's like a very, very tiny, like the thrust. That's like 1%.
Yeah, right. I was going to address the second point. Right. So I guess regarding the second point, so, right. So the idea is that, look, even if the universe is infinite, the physics will mean that there are certain quantities that like have to decrease or increase over time or something. And so then we should say the same thing about value.
Not just that we should, like,
so
the physicists do say that. Like, this is like in the consensus of physicists. Like that's not even to not say that puts you outside of not just the consensus, like it puts you outside of like every physicist.
Right. So I guess one way So one way I'm just hearing this challenge for the first time, so I guess one way of doing it is you might think that there's a way of comparing so often there will be two infinite sets that are incomparable. But then so it's like there will be there will be two sets, three sets, A plus, A and B, such that A plus is neither greater nor less great than B. A is neither greater nor less great than B, but A plus is greater than A. So for example, suppose that A plus is just A with a sort of random addition of an extra member. Then there's a sense in which A plus is the same as A, depending on exactly how you do measures of infinites. But A plus is not, but then neither of them can be neatly compared to some other set B. And so maybe what you could say is,
yeah. So what? How does it tie into what's the way of so in the case of entropy, what's the way of like, or Gibbs free energy? What's the way of preserving what you've said while also preserving the laws of physics?
Well, sorry, maybe it would be helpful for you to explain sort of like what it is that has to increase or decrease over time or something.
Yes.
Just explain a bit more.
Yeah. So there is there's laws of thermodynamics, and the second law of thermodynamics states that in a closed system, there is a secular tendency for entropy that has to increase. And what that means is that the value of Gibbs free energy, which is the amount of energy available for work, must decrease over time. So
what's work? Sorry, I don't know anything.
Work can be expressed in terms of force times distance. So if I apply a certain force to a given over a given distance, there will be a certain amount of joule of work. That's the SI units. There's multiple ways of expressing work in terms of, it's a way of like, you can take energy and I hate to say take energy and put it to use, but that's not really a very good technical way of doing that. But work is essentially energy, and is a form of that is in the form of an application. So you can take energy and move an object, for example. So if I push an object, if I apply a force to an object, I haven't done work to an object. But if I use that force to move an object across a given distance, then I have done work. And that work is would be represented by the force that I applied to the object, multiplied by the distance the object has moved, and of course it's the cosine of the angle that applies to that object, because I can So or just work times distance, assuming the angle of the vector is in the same direction of the movement.
Maybe one way to go. Wait, I'm sorry. Just briefly before we continue, I saw the room was it said fine tuning and fish. Sorry, my understanding had been we do the fine tuning debate and then we do like a YouTube stream about fish. Would you be up for that? Or
Oh, you mean you could stream whatever you want on your channel. I can stay right here. You can use your camera here if you want.
Yeah. I was planning on doing like a StreamYard thing if that would work. No worries if not.
That's I mean, that's fine. It seems like we're going to go back. There's going to be a number of back and forths. Why can't you just StreamYard from your end?
Yeah, I guess I could. I feel like the format's a little bit better if it's not like in a Discord server, but it's fine either way.
Yeah, because I prefer to just like not have all the audience and everything bounce back and forth. But anyway, but let's figure that out at the transition.
Yeah, sounds good. Okay, so I guess one way of going is
but do you understand what the issue? Like, just I want to make sure you're so
yeah.
What Gibbs free energy is, it's the amount of work in the universe. Sorry, it's the amount of energy in the universe that is available for work. And so the idea is that in a total state of entropy, there is no amount of energy in the universe that's available for work. Because there's no heat differential. There's no energy differential. You can't use an energy differential to make anything work. It's just a bunch of homogeneity.
Yeah.
So
yeah, I get the core idea is that, look, you have to have work. So you have to have the free energy.
Yeah, there's a certain amount of thing. This is not just this applies to a whole bunch of, like, it can apply to anything.
Basically there are certain parameters in physics that have to be increasing. Yes. And then once you grant they're increasing, then the cardinality response becomes problematic. Mm-hmm. Because so I guess what I'd maybe want to say is that I think maybe the word increasing is polysemous, such that there's sort of like the sense of increasing relevant to physics is different from the sense of increasing relative to ethics. Where so suppose that and then the sense relevant to ethics is, in that sense, they're not increasing, because that sense is about cardinality, at least maybe with a few bells and whistles.
Wait, you have to break this down. You have to explain this to me.
Sure. So maybe, so let's imagine that. Let me see. So let's say that there are infinite galaxies, okay, and there are two times, T1 and T2. Let's say at T1, each galaxy has one person, and then at T2, each galaxy has two other people.
Right. So the cardinality people is the same at both time points.
Right. And so what you might say is, look, there's a sense in which, I don't know, take some parameter in physics. There might be a sense relative to physics in which it appears that the math is in which you'd say that the mass is increasing. But then in the sense relevant to ethics, you'd say, no, the mass is staying the same. And one way to see this is that you could transform one scenario into the scenario where every galaxy has two into the scenario where every galaxy has one, just by moving the people around. And so provided you don't think that moving the people around makes an ethical difference, then you're inevitably committed.
What I'm not understanding here is just, I'm not seeing what breaks. I mean, again, it's not the issue here is that the thing to explain is that there's a value of a certain amount of thing in the universe that appears lower than what it should be. So regardless, just like if someone said the universe was fine-tuned for a state of entropy, I would say, well, why isn't the entropy higher? If someone said the universe is fine-tuned for life, analogously, one might say, well, why isn't the value of life forms higher? Or why isn't there more life? I don't see how there's a symmetry break here. Both of them are there's an expectation of a number, or there's an expectation of something greater on both.
Right.
Ideas.
So that, yeah,
And it also doesn't need to be ethics. Like, it doesn't, like, this idea of, like, it's just something that is being posited. It's a physical thing that's being posited by a theory. Like, life is a physical thing. It's like, you expect life. You expect entropy. There's not more life. There's not more entropy.
Sure. So my suggestion was, when you talk about increasing, my suggestion was that the word increase is polysemous, where
What do you mean
there might... Sorry?
What do you mean by when you say it's polysemous?
Like, there are multiple coherent senses of the word, so that where common usage underdetermines the meaning. So I think there's one coherent sense where it's just about cardinality, and then there's another coherent sense where it's not just about cardinality, but it's about, I don't know, maybe
like density.
Yeah, maybe something like that. Yeah,
sure. That also doesn't work. But yes, the problems go even deeper.
Right.
So yeah, I anticipate these approaches. There's approaches that you can say. Yeah, so there's going to be approaches. So first, I mean, before I get there, I mean, just so you know, like, this is a huge problem, and like I've looked into this. There's different ways you can try to save it. There's ways of, like, reformulating and to try to make it like, well, it increases in terms of density. You can look at ratios, stuff like that. It runs into a whole bunch of problems that everyone agrees hasn't even been solved. But But before we even get there, so I agree that one could say that, really what we mean by, really what one means by increase is, in an absolute, not in an absolute sense for one, but not an absolute sense for another. So one might try to save this by saying, well, in the case of fine tuning, one only would want to generate life in an absolute sense, and so the objection doesn't work because it's infinite. But what physicists mean, it would be more of a density thing than an absolute thing. So that doesn't. So that, and in that sense, you can save it because you're not relying on the absolute sense. So it can increase in density even if the cardinality doesn't change in absolute sense. But we still can't backfire on the objection for the fine tuning because we mean it in the sense of absolute sense, and so that is just infinite. Fair?
Yeah. So, but my thought was, right. So maybe you have problems with, like, using density as the way of doing it,
or any way of doing it in which the but go just about any way that's known to physicists.
Right. But I guess but conditional on the universe being infinite, which my sense was we were just sort of like granting the universe was infinite, because this objection was like, even assuming the universe was infinite, you have to say
it is. Yeah, granting it is. Yeah, sure.
Yeah. Right. So my sense
was, there's more. The biggest problem is that's not the sense. Well, the first biggest problem is. One big problem is that's not the sense physicists mean it, by the way. Like, physicists will tell, even the ones that believe it's infinite will tell you that the universe is still an isolated system. The second law of thermodynamics holds in the sense that the calculated, whatever absolute value of Gibbs free energy there is, that value is decreasing over time. And
when they talk about it decreasing, they're not talking about cardinality. Right.
They're saying it would, if it's the absolute value that's decreasing, they'd have to talk about cardinality. What else? What else? If it's the absolute, it's not based on a ratio of the over given. They may agree that it is also as a ratio.
They're suggesting that the cardinality of the
Gibbs free energy. Yes.
Yeah. That the cardinality of that changes.
Yes, the amount of joules. We can say the amount of joules that's available for work in the universe, right? That's a number, whatever it is. Presumably it's whatever value it is, actually.
And the value is infinite, right? If the universe is infinite.
Well, yeah, I mean, that's the problem. The problem is, how could one, the problem is they do believe that the cardinality decreases. Like, the value is just dropping. But how could it drop if it's infinite? And so if we don't have a physical mechanism to break that, it's
right.
So
but So I guess what
Now,
are the
I can tell you what
proposals?
their approaches are to get around that, but their
Yeah,
approaches
sure.
are
Yeah,
nothing
maybe.
mine.
Yeah, why don't you tell me that?
Yeah. So one approach is one approach is sort of along the lines of what you have mentioned, which is well, they don't do this for the for the Gibbs free energy, but they would do this for a number of other things. They could say, well, what maybe what we can do is we can we could frame this as a sort of ratio. We can say, well, the value of the Gibbs free energy as expressed over a um, given amount of cubic meters. You know, this is one thing that can be done. They don't really do. I shouldn't say they do this in the context of entropy, because I don't think I've seen them actually do it for this thing. This might actually be just a big another thing, like people who believe the universe is infinite may haven't fully realized. But what they could do, they don't, as far as I know. They just try to say, okay, well, because they really do say the total, like they very strongly assert that the universe is an infinite, even the infinite universe is a closed system, and it has a decreasing value of joules in Gibbs free energy. But what even if you wanted to try to do something like say express it in a sort of like ratio sense, like, okay, well, maybe the density of it, or maybe like amount of Gibbs free energy over a given cubic meter, well, that clearly is decreasing in cardinality, even if the total amount may be infinite. But it turns out that runs into another problem called the measure problem, not to be confused with the measurement problem. It's the measure problem, which has to do with comparing infinite ratios by carving out finite spaces in the universe, while maintaining an applicability to the value of while maintaining applicability to extrapolation to the universe. And it turns out when you try to do this, you either generate completely erroneous results in terms of values that either are not physically possible, values that are completely unexpected by Penrose orders of magnitude or something crazy like that, or you generate crazy paradoxes like the Young's paradox. And there's been a whole bunch of physics that has tried to do this, whether by carving out finite spaces of the universe in terms of space, in terms of time. They've tried to do this with certain notions of proper time, and it turns out none of them work. None of them. None of the ways of doing this to try to save this problem, which is really, by the way, ironically enough, it's actually classically known to be a problem with multiverses, but it actually applies just as equally to any infinite universe. So they've tried all sorts of ways of carving out finite space to try to express this differently. And by this, we mean just any sort of ratios in which we're dealing with this sort of infinite problem, to try and come to some limit for an answer. And these different ways of carving finite quantities out are called measures, hence the name measure problem. For those who are interested in reading further about the measure problem, I'll just drop a link in general chat. You can browse the wiki on it or whatever. So it turns out that there really is, if there's anything that's agreed upon in cosmology, I think, even among those who think the universe is infinite, it's that there really is no good solution to this problem. But and then maybe that's just a function of like we just don't have the mathematics to handle it, or something like that, or that what some have admitted, it's like, okay, well, maybe the universe just isn't infinite. But what I don't think anyone does is they say, all right, well, this thing just what I don't think anyone does is they bite the bullet on the measure problem in a way that you could just bite the bullet on something like the repugnant conclusion. Like no one bites the bullet and says like, okay, well, the universe just is succumb to infinite fuckiness. And just when
Like,
we... Sorry, what?
Like no one like bites the bullet on like the youngness paradox and thinks almost certainly we're a Boltzmann brain in the first millisecond of the universe. Right. Yeah. So I guess I think right. So I obviously I don't have a strong view about like what the right solution to the measure problem is, or like I my sense is right that it there's not any agreement about it about what the right way of doing the measure is, right? But I don't.
The agreement is that there really is no good solution to it that has been ever discovered. But no one,
yeah.
but no one seems to think that that's a reason to start biting bullets on. No, they may bite the. No, the point is that they may bite the bullet, even if someone does bite the bullet on the youngness paradox, which they don't. Like I think the easiest bullet you could bite on is like high imprecision to like orders of magnitude, which is a really huge bullet to bite. But
sorry,
like you're gonna just generate terribly hard like results, like shit, like results that make very little sense. They're like incredibly imprecise by like many orders of magnitude. That is a huge bullet to bite, but that's probably the least problematic bullet to bite. But what they definitely don't bite is they don't go and start biting bullets and say, well, now we just have to come up with this completely different notion of the laws of physics, and we have to just start doing all this stuff to say like, okay, well, really, the bullet they don't bite, plainly stated, is just that the total value of Gibbs free energy in joules of the universe is not actually decreasing in cardinality. Like, I don't know anyone. I don't think anyone bites that.
Wait, not actually decreasing in cardinality. Wait, sorry. Maybe I'm confused. Sorry, cardinality is the measure of the size of an infinite set, right? Or is it just
cardinality can apply to? Can't cardinality apply to sets of 3 or 4?
Wait. Oh, yeah. Oh, okay. Yeah. Sorry, I'm stupid. Yeah. Sorry. Okay, cardinality is just the size of a set. Okay, makes sense. Yeah.
So. Yeah, so they're going to say that the cardinality of the value of joules of Gibbs free energy is in the universe is decreasing. Like no one bites the bullet that that's not true. There's a whole lot of problems that lead. There may be a whole lot of issues that lead to that.
Wait, sorry. Is it true that like the way they'll measure sets will be not in terms of like traditional cardinality measures? Right, so people who are trying, like, for example, it's not like the Gibbs free energy will go from like Aleph null. Sorry, will go from like Beth 1 to Aleph null or anything like that.
No, it's not. We don't know if, like I said, we don't know of any. I'm not aware of any physical process. There's ways you can do it in math, but I don't know of any physical process that traverses infinite cardinals like that.
Sure.
But cardinality. I don't know what you mean by traditional cardinality as opposed to non-traditional cardinality, by the way. But yeah, cardinality just it's just the amount of the amount of the number of things, like the amount of things in a given set, like the number of elements.
Okay, so what I had thought, and I might just be totally wrong, but I had thought that cardinality was what I thought 2 minutes ago about cardinality was wrong. But I thought cardinality was a measure of whether members of a set can be paired 1-to-1, right? So two sets of the same cardinality, if there's a bijection between them, they can be paired 1-to-1.
Well, those are some things that get mentioned in cardinality usage, like when people start talking about, if
my sense is, for example, that if you have, and we might be getting a bit off topic.
Right. As long as we are on the same page of cardinality now, that's cardinality means the amount of elements that a set contains. It's like if I have a bag of 4 apples, the cardinality of the apples in the bag, it's 4. Like that's the cardinality.
Yeah, but sorry. So if So suppose you have some way of taking a measure over infinite sets, and both of them have Aleph null members, but the way you take you might have a way of taking a measure over infinite sets that says that there are more naturals
within one infinite set than another in some sense. Right, but that's getting back to the measure problem. So there's ways of trying to do that. So yeah, so yes, so
sorry. Right now, I'm just asking a terminological point. Sorry.
Okay.
So if just to be clear, if there are two infinite sets and you can pair them one to one, but one of them has a bigger measure, would you say they're the same cardinality or a different cardinality?
A bigger measure, in the sense of the measures are going to be. I mean, the measures I know of in the measure problem are finite. They're cutting out finite sections of the universe. If you're using the term measure in cosmology, when you say
yeah. So sure. So I guess so maybe there is a sense in which you can talk about even in an infinite universe them getting smaller. But what I'd want to say is that in the sense relative to ethics, relevant to ethics, what I think matters. So a perfect being is motivated purely by ethical considerations, and the only reason why they'd want to create more happy people, more life rather than less, is if it's better to create more life rather than less. Now, in terms of a being, what my claim is that what's relevant to the kind of ethical side of these sorts of evaluations is whether or not you can pair them one to one, right? So even if you have two infinite sets, even if you say one of them is in some sense larger by taking a measure over it, I think that in terms of the ethical evaluation between them, generally, if there's a bijection between the two of them, between the members of the sets, then generally they'll be equally good, barring some exceptional circumstance.
Wait, I'm not following. The issue I'm having is I just think the whole thing doesn't end up working. I think the whole move, say, because even if you want to say that even if you want to take it in terms of, what I'm not understanding here is like, okay, so the move here is not to say, like, in some sense, like they say, well, I guess it is in some sense, because that subsumes a lot. But what's being said here is that there is a physical thing. What I'm not understanding is there's a physical thing that in both cases, in both things, there's some sort of physical prediction. Like, whether by ethical concerns, a universe is predicted to be tuned for Gibbs free energy, or by ethical concerns, the universe is predicted to be tuned for life. Like, in both of those hypotheses, there is a prediction of some amount of that thing in question, some amount of Gibbs free energy and some amount of life.
Sure. So yeah, so my thought was that maybe the Gibbs free energy thing, that's increasing or decreasing even in an infinite universe. But I don't think when deciding, so what's relevant to this is how a perfect being would make evaluative comparisons between different universes with different sort of density of life, right? Whether such a being would prefer life where a universe where there's life, say, a million times galaxy.
What's being said very simply is why isn't there more? Whatever said, you could fill in the blank in whatever sentence. You say, why isn't there more? Just like you could say, why isn't there more Gibbs free energy? Say, okay, well, why isn't there more Gibbs free energy? Because look, if someone posits that the universe is tuned for Gibbs free energy, one can ask, it's a legitimate question to ask, why isn't there more Gibbs free energy? Just like someone says, okay, it's fine tuned for life, why isn't there more life? And all I'm saying is that if the move is to say, haha, ta-da, I skirt around that problem by saying the universe is infinite, like, that leads into, and by the way, we've scratched the surface on problems with this. Like, there's a whole litany of issues by saying, well, there is nothing to answer because the value just is the maximal. It just is infinite. So what I'm saying is that move there is not a legitimate move. And the reasons it's not a legitimate move is it leads you, it does quite straightforwardly lead you to reject laws of physics, and even attempts to save that, they go against what physicists say, and even they don't work for other reasons. And so what I don't understand is, if we posit those two different hypotheses, the Gibbs free energy, to the Gibbs free energy tuning and the life tuning, I'm not understanding what separates. If they're both motivated by ethical concerns.
Wait, what? The Gibbs free energy thing is motivated by ethical concerns?
Let's just say that there's a being that has fine-tuned the universe for Gibbs free energy out of ethical concerns. Then the question is, well, why isn't there more Gibbs free energy then? Just like a being for ethical concerns has fine-tuned the universe for life.
So if there's infinite Gibbs, so like, or as a simple case, you could imagine that the Gibbs free energy was conscious or something, and then you ask, why isn't there more Gibbs free energy?
Yeah,
and I guess right. So there, I would just buy a similar response there, where I'd say there might be some perfectly well-defined sense in physics where you say that the Gibbs free energy decreases over time. But in the sense relevant to ethical evaluations, I think the sense relevant to that is bijection. Otherwise, you can change around how good a state of affair is by shuffling the people around.
What do you mean when it's wait, what do you mean bijection? What's the sense? Like,
so my thought.
What's the sense in which it can't be low, it can't be more, or like, because that's what I'm looking for. Like, what's the sense? Because the response is the question is always why isn't there more? And the response is just that, well, here's a sense in which it is more, it is maximal or something like that. So what is that?
I think the answer is because whether there's more or not doesn't actually affect anything that matters. And here's one way to see this. So imagine, so stipulate the universe is assume the universe is infinite. And let's say that you have just for a simplifying assumption, you have each galaxy has 1 million planets. And let's say each galaxy has life on one of the planets. And then you ask, why isn't there more? Why isn't there life on every planet? Well, you could make there be life on every planet just by moving the people around. You could take, the people from the first 1 million galaxies, move them to.
Well, wait, no. When they say more, it just means why isn't the total amount of people? That's a density thing. I'm asking, why isn't there more people? Like, for example, like, why isn't there n+1 of however n is however much many people there are right now? Why isn't there n+1?
So, right. So you could always, right. So you're asking, your question is not, your question is not about why there isn't some distinct state of the universe where there are more people. Your question is just why aren't there just like additional people who could be made?
More than we have now.
Yeah.
Why aren't there more people? Yes. Like, why? It's just like I could say, why isn't there the amount of Gibbs free energy, the amount we have now, plus 1 joule, or plus any amount of joules?
Yeah. Right. So I guess I would agree the answer I've given so far doesn't suffice to answer that question by itself, because I think the addition of an extra happy person would be a good thing, even if the universe is already there. I guess there are a few ways I could go in response to that. One of them is just to say, look, provided that the amount that God can create is unbounded, so provided he can always create more stuff, then he, at some point he has to stop, right? He can't, he has to stop at some point. And so there's no reason why once he makes infinite good things, there's no reason why he can't create more.
He does have to stop at one point? I thought he was omnipotent.
Well, he's omnipotent, but if you think that no matter how many people he makes, he could always make more, then there's no maximum. So just like an omnipotent being can't pick a greatest.
Yeah, I don't know. I may not know where So I may. So then the issue would be, well, I may not know, where the stopping point maybe, even if we posit all of that to be true, but it like similar to the Wright's brother analogy, like I might not know what the perfect plane is, but it's not the Wright's brother plane. If we scoured the universe and only found a few joules of free energy, we could simply say like, okay, well, mate, was it really just 3 joules that we had to stop at? So yeah, I mean, I could say like, looking through the entirety of the universe and saying like, okay, well, we've only seen life on this planet, and even if we count up all the life forms, all things considered, it looks pretty small. So it would be like, really, like, okay, yeah, I mean, maybe you do have to stop at some point. That's maybe in contention, but even if you did have to stop at some point, certainly there are values for which it would look pretty silly to stop at.
Right, just like right, like if you claimed, oh, this is a perfect being, and then they make like 6 good things, you're like, wow,
Yeah.
why only 6? Even if they have to stop at some point,
Right?
Yeah, right. So I guess I would grant that if there was only a very very small amount of good stuff in it, but once you grant that there's an infinite amount of good stuff in it, and potentially an arbitrarily large multiverse where there's infinitely more good stuff, right? So maybe even a higher cardinal, like maybe there are some more than Aleph null good.
By the way, I don't see how a multiverse would increase the cardinality of the infinite value.
Why?
Because it would
Like,
just
couldn't
be
you
like
just make like Beth 1 good things? Like
it may be logically possible to increase it. I'm not saying it's not logical. I just don't see how the existence of a multiverse accomplishes it.
What if you made a multiverse? What if you made a multiverse with some higher cardinality of good universes? Right.
Wait, I don't understand. So it would just be analogous to like, let's say like how many let's say we have 2 sets. Let's just make it simple. Like there's 2 universes. One universe has all the odd integers, and one universe has all the even integers. The cardinality of both of those universes is infinite, but the cardinality of all integers is still is also Aleph null, and so the subsumption of that multiverse is still going to be Aleph null.
Right. Well, right. So if you make Aleph null universes, then the number of good things won't be more than Aleph null. But God could make Beth 1 universes or Beth 2.
Okay. So right. But okay. So that's just. But now that's you're saying something different. Now you're not saying that the mere multiverse does that. You're saying there's some way in which God does
I
that.
didn't mean to suggest that just like. Right. Obviously, if you only have like 3 other universes, right,
or even an infinite other, just even if you could have infinite other universes, that still won't increase the card.
Sure, right. Yeah, 3 infinite, so long as it's right. But if you have a higher cardinality of infinity, as I think there's every reason to expect that to do.
So I'm just saying that we don't know of any physical mechanism that does that, even including multiverse. But it could, it's possible a god could do that somehow.
Right. Well, and also, I mean, if a god does it, it's not clear that there would be a physical mechanism. Like he could just have just like
the point anyway. Yeah. So anyway, what I'm So okay. So what I'm saying is So but now it seems like you're just going back to the infinite savior again. But we already went through that. It's that this gets completely fucked. The infinite savior.
Sorry.
Response.
Let me give you my sense of how the dialectic went. Sorry. Okay. Yeah. My sense of the dialectic was. So I suggest you ask, why doesn't God make more stuff? I say, well, maybe God already made infinite things, and so he can't make more stuff. Mm-hmm. You say, well, even if God made infinite stuff, there can be more stuff. Otherwise, you basically have to give up on all of physics. And I say, okay, right, but if God already made so maybe God, has to make infinite. Maybe he can make more stuff. Yeah. But if God can always increase the amount of good stuff that he makes, he has to stop. He has to stop it there. Like there isn't any maximum that he could create. So all he has to do is create a very, very large amount of good stuff. And then after he's created a very large or an infinite amount of good stuff, he has to stop at some point. Then your response is, well, sure, he has to stop at some point, but he doesn't have to stop at some.
He doesn't have to. He doesn't have to stop at such a low value. And your response is, well, if the universe is infinite, it's not a low value. Now, but that's going to fall afoul to a very similar response that I gave initially to the infinite savior argument. And so because actually. So the Gibbs free energy is on the laws of physics is entailed to fall to 0, and one could always say, well, if someone is analogously trying to tune the universe to Gibbs free energy, one could always so you're trying to give the same defense again for a different purpose. You're saying, okay, well, the defense is not just to say that there couldn't be any amount of more. The defense is just to say, okay, well, this actually does seem to be like a lot of it. And I would contend that so I think that just runs afoul of a very similar objection, just parallelly modified with the same response I gave. So analogously, that we can have decreasing values. We also think that there's going to be small values on the Gibbs free energy. So it's not just that any value can change, that it's entailed to reach zero. In fact, the state of entropy of the universe on many of the cosmological theories is at a minimum point, which means Gibbs free energy is at a maximum point at the Big Bang. And then it entails eventually the heat of the universe to reach zero Gibbs free energy and maximal entropy. And so it's not clear how you would be able to reach small values if you have a defense mechanism of this. If you have this defense mechanism of not just to say it couldn't increase, but it's not even a small value. It's not clear that we could ever get to small values, but in the laws of physics, we think we can get to small values. So this is going to run afoul of a very similar sort of objection, just slightly modified. And then we're back into the same dialectic again.
Wait, I think I did not quite get your response.
Sure. Yeah. So the problem analogously, the first thing you mentioned was that, well, there is no more that could be created because it's just infinite or something like that, so the problem is that with that is that, well, the laws of physics entail that there is more that could be created, or that because of for things like analogous entropy concerns.
I grant more that more
Sure.
could be created. My point is,
No,
matter.
I know. And then your next move is to say, well, it seems like a lot has already been created. Because but that the problem there is if you use that escape hatch to say it seems like a lot has been created, that's going to fall afoul to a similar problem, which is just to say again. So first of all, I'm just going to start it off where I said in the beginning. You should have an intuition that this move is a very cheap one. Hopefully you have a bigger intuition about it now than before, even though it's infinite, about intuition about infinites. And then the reason is because if that were true, it's not clear that we could ever reach small values like this. Whatever.
Wait. When you say, what do you mean when you say it's not clear we could
any theory on an infinite universe, any theory that could have an objection for small value generations, like any theory that predicts a small amount of something, would never predict a small amount of something because it's infinite. The thing that's there is infinite. So any theory that predicts a small amount of rocks would never predict a small amount of rocks. Any theory that predicts a small amount of people would never predict a small amount of people. Any theory that predicts anything that there is in the universe, no theory would ever predict this, because or at least successfully predict it, because one could always say it's infinite, and so there's an infinite amount of it. But the problem is the laws of physics entail that there is a small amount of something, namely, at least at one point, a small amount of Gibbs free energy. But the problem is, if the universe is infinite, there will never be a small amount of Gibbs free energy.
What do you mean? In what way do the laws of physics entail that there's a small amount of Gibbs free energy? I understand that it entails it entails the amount decreases.
Yeah, but, sorry, that there will be a small amount of Gibbs free energy.
What will the small amount be?
Zero.
Okay, it will be zero. Okay, fine.
Yes.
Yeah.
It will be in heat death. But the problem is you could never get there. There would never be, if you take this thing to work, it's not clear that you could ever get there, because you could always posit, if the universe is infinite, you will always be able to posit that there is some space in the universe where there's non-homogeneity of energy, and there would never be the value would really of the totality of the universe would never be zero in totality. Like analogously, this also cuts against.
I don't get why that applies.
So
yeah.
So
sorry. What I'm not understanding, to be clear, is the inference from that if there's an infinite amount of life, then sort of like God already is satisficing. I don't understand the inference of that to the Gibbs free energy would never reach zero.
So the problem is when you use this, okay, it's a problem with the general strategy you're using. You've basically just used the general strategy for a different purpose now. And the general strategy is to say, well, there's some value that's not expected on the theory, but that's never a problem because infinite universe, though. The only difference in what you've done now is instead of saying, well, why isn't there more? You've used the same strategy to say it's more than a small value. But the problem is, even that goes against our understanding of physics. Because if the strategy works, if that strategy works, which is to say, we expect a large amount of something, we observe a small amount of it, but really, we didn't observe a small amount of it because infinite universe, though. If that strategy works, then it also cuts against our current understanding of physics because the Gibbs free energy would never reach zero if the universe is infinite. It's not, or at least because if the universe is infinite, there's at any point in the universe, in an infinite universe, anything within the bounds of the laws of physics of the universe that can happen essentially will happen, and so there will be some point of non-homogeneity of energy distribution, and so there will never be a zero Gibbs free energy value. There'll never be a heat death of the universe, which is also against our current understanding of the laws of physics. So it's a problem with the general strategy you're using. It's not a problem with like any theology. It's just a problem with the strategy of defense you're using. You're using a defense strategy that it accomplishes it's basically what you're doing is you notice a fly in the house, and you, instead of taking a fly swatter to the fly, your solution is to take an atom bomb to your house. It works, it kills the fly, but it completely destroys the house. If your strategy works, if your strategy works here, this whole strategy of saying, oh, we can always save the theory by saying this low value isn't low because infinite universe, though, that's going to cut against a whole bunch of stuff we don't want to cut against.
Yeah. Sorry, I think I may just be being stupid here, but I feel like I'm not seeing the picture. Maybe would you want to like type it out or something? Type out the steps, maybe.
Okay, so let's do it like this. I'm trying to. The answer to your question is, I mean, I can, but I kind of don't want to. I'm trying to think of a way if I can explain it better before I do that, because I like talking instead of typing. So let's say we have some theory that, well, let's just take it to be like the case. Okay, let me I'll try one more time instead of like, and then I'll try to think if I can think of a novel way to explain it. So let's say we agree that on our understanding of physics, the value of Gibbs free energy is going to be zero. It's going to reach zero, i.e. the heat death of the universe. There's no available Gibbs free energy for work. However, if there is an infinite universe, then there's always going to be some there will always be some spatial location, no matter how rare it is, where we find something that is extremely rare. Like it doesn't, and it wouldn't matter how rare it is. It could be 10 to the power of -100. and we'll find it.
So if the universe is infinite, then the Gibbs constant would never actually reach zero.
Yes.
That's the thought.
Yes. And
Okay.
so the problem is, but our understanding of physics is that the Gibbs free energy of the universe will reach zero. And so the problem is that this strategy, they will therefore cut against our understanding of physics. The strategy of saying, well,
Wait, sorry. So wait. Sorry. Is it true that of the people who think the universe is infinite, do they think the Gibbs free energy will reach zero?
Yes, that's correct.
Okay. And sorry. And why does Okay. So then maybe what I'm not understanding is
your strategy, your general strategy cuts against it, and the reason your so the general strategy. So if the universe being infinite entails that the Gibbs free energy will never reach zero, and our understanding of physics is that the Gibbs free energy does reach zero through this does reach zero. But if the Gibbs free energy, if the universe is infinite, the Gibbs free energy will never reach zero via this strategy. It's via the feature of the strategy that you're employing that makes it never reach zero. Because of this feature of no matter how rare something is, it will always obtain in some space in the universe. No matter how rare life is, it will always obtain over and over and over again. No matter how rare it is, there'll be infinite of it, namely. So as a feature of this strategy, which is essentially which would save any theory from any counter observation, any unexpected observation that has a low amount of something by just saying infinite universe, though, that also will cut against our understanding of the laws of physics. Because as a feature of that strategy, the feature of the strategy is to just say, well, it doesn't matter that we observe an incredibly low amount of it and think it's low. It's never going to be low. It's always going to be infinite. Because infinite universe, though. And if infinite universe, though, then no matter how rare something is, it's always going to obtain. And not only will it always obtain, it'll always obtain infinitely. And so there will always be infinite Gibbs free energy. And there will always be infinite life. And so...
Wait, sorry, my response, I don't... I'm sorry, my response, I don't think entailed that there would always be infinite life. It just entailed there will be infinite life. The point is that even toward that there is infinite life. Well, that does entail yeah. And so the problem is even at time. So point is that the problem with this strategy is that even in the case of the universe, at any point in the universe, because largely because of a feature of the second law of thermodynamics being at least in part a statistical phenomena, the value of Gibbs free energy in an infinite universe just doesn't reach zero. It's infinite. It's an infinite universe, and so no matter how rare it is for some kind of spontaneity of a violation of the law, in which, or at least a local change in homogeneity, that's just going to always obtain. There's always going to be some. There will always be some non-homogeneity in energy density, and so there will always be some value of non-zero Gibbs free energy in the totality of the universe. And so it's by the same token, it's just the same. Look, it's just the same strategy. You can always take something that should be extremely low or even zero, and say that, well, because of the feature of an infinite universe, that no matter how rare something is or how uncommon something is, it just will obtain. Our understanding that radically changes our understanding of the universe currently. That would have implications that we would no longer think there is a heat death or a true heat death of the universe. We would no longer think the value of Gibbs free energy will approach zero. We would have to change our current understanding of cosmology if this strategy works. Sorry. So, yeah, and I once again apologize for my slowness on this point. But so, so with both the Gibbs free energy, we think it's infinite now. With both it and life, we think they're both infinite.
Can I speak up for a second?
Yeah.
It feels like we're having trouble getting on the same page about like what the problem is. And it seems to me like it's kind of because we're being a bit more granular than we need to be. And if we like zoom up to look at it like a bit more abstractly and then get the big picture framing, then it will be like easier to talk about the details of Gibbs free energy or whatever else. Avi, it sounds like you're saying that Matthew wants to deal with rarity by invoking the universe being infinite, and you think that he's done that twice. There's a general thing he's doing there. And you think that that entails that you think that creates problems because the universe being infinite is at odds with modern physics.
I think you'll notice. I think just almost any invocation of that to save theories in this way is a completely illegitimate move that generates all sorts of problems. Like, yes.
Yeah. So let's like split it up from invoking it in this way because that binds it all up with rarity and all this stuff. Just one totally separate thing. Obvious saying whatever you do, if it gets you committed to an infinite universe, you're in trouble. Correct, Avi?
Not just no. That's not true because there are people. I'm saying whatever you do, if it commits you to saying that an infinite universe is a savior move for these problematic rarity observations, it fucks you.
Okay, why does it matter?
You can believe in infinite universe. That's fine. I don't have the issue with that.
What the issue I think is that's at odds with modern physics
is the move of saying the conjunction. The move is that infinite universe is not at odds with modern physics. That in and of itself is not. Like, there are physicists who believe that. The move that is at odds with modern physics is to hand wave away any rarity problems by saying infinite universe, though. That move, that general move, is what I'm taking issue with. I'm saying that is an illegitimate move, and that has a whole list of problematic entailments. Some of which violate laws of physics, some of which put us at odds at our understanding of physics, some of which leads to paradoxes, some of which leads to, and some of which, by the way, just backfire on fine-tuning. But we could get into that. But
sorry, maybe I understand the picture. Sorry, let me see if I'm getting this right. So you're thinking what I'm doing is analogous to the following. So let's say you let's say there were two theories, okay? And one theory predicted that on average you'd get only one atom of iron per galaxy. And the other one predicted in terms
of a density prediction. My issue is broader than that, but yes, go ahead.
Right, sorry. I just want to give this example to see if I'm broadly getting it.
Sure.
Okay. So one of them is that one theory predicts that you'd get roughly 1 millimeter of iron per galaxy, and the other one predicts that iron would just be very abundant. Okay, so what you're saying is what I'm doing is like the following. So we find ourselves on a planet that's just filled with iron, and you say, "Oh, surely this confirms the first theory." And I say, "Well, hold on. I don't think it confirms the first theory because both theories predict that there are going to be an infinite number of galaxies with any particular quantity of iron, right? Because even if on average they only have 1 millimeter of iron, there will be an infinite number of galaxies that are entirely iron." And so you're thinking what I'm doing is now.
You have the general idea. I think you confuse the two theories up there because, but sure, yeah. I think the first one you mentioned is it predicts 1 millimeter, 1 ml of iron. Per galaxy.
Okay, I see. Yeah, so I guess what I want to say is that
the observation would be we only observe 1 milliliter of iron. So we only observe 1 milliliter of iron is the observation, and then you say, okay, well, certainly theory 2 is wrong then, because we would observe, I don't know exactly how much iron is, but we would observe a lot of iron, whatever a lot means. And then the move there is to say is, well, we actually do observe a lot of iron because infinite universe, though. And this could apply to any theory, that predicts any different quantity in the universe, and your conclusion is neither theory really makes any different predictions, because they all predict an infinite amount of it.
Yeah. So I guess my thought would be the difference would be that that I think that there's a kind of like anthropic response to the first one in a way there's not for the second one, right? So in the case of the iron analogy, if you had
But by the way, that's not.
um,
Just to be clear, that's not even my issue. That's a separate issue. That's probably tier 3. That's not even one of the issues I had in mind. It's an issue you're bringing up, but we can add it to the list. My issue is this move violates our understanding of physics. Just to be so, yes, there's concerns you're bringing up. So the move you're bringing up right now is an epistemic problem. Like, okay, well now we have an epistemic problem of how we compare theories if we're going to use this strategy. But so yes, that's a relevant concern, and maybe you can generate some response to that. But that's not even what I'm mentioning now. What I'm mentioning now is this just cuts against our understanding of physics.
Okay, wait.
Yo, I'm sorry, but can you clarify what exactly the move is?
The move is to hand wave away any concern with observing a small amount of something on a theory that predicts a larger amount of it by saying infinite universe, though. Because if the universe is infinite, we never observe a small amount of anything. We always observe a large amount, namely an infinite amount.
Okay.
And so what I'm saying, if that move works,
wait, let me make sure I understand the move. The move is just that theory predicts a lot of something, then you take it as a datum that there's a little bit of it because that's what you observe. And the idea is to say that datum is actually wrong. There is actually infinite of it because the universe is infinite. That's the move?
Yeah, that's the move.
Okay, so it's a kind of way to try to take a datum that counts against your theory off the table by saying that observation doesn't count. Actually, the observation is different because infinite universe. Yeah.
Yes. Yeah, the infinite universe. So let's call that the infinite universe, though, move. It's
okay.
So now there's a whole bunch of problems with this. I think I'm at like at least 5 problems now. 4 of which I think are just completely devastating. But the 5th one is, I think Matthew may have a solution for. So the one Matthew seems to be getting at is like, okay, well, this seems kind of silly epistemically because, like, well, how do we predict anything on theories? Because, like, we have lots of theories that, well, there may be some theories that work, but we have lots of theories that predict certain quantities of things, and it doesn't seem like we're going to be doing a good job of generating predictions if we could always say they predict an infinite amount of them. But that's not even where I'm at now. We can talk about that, but my big issue with this is that if we accept this move, we are going to have to accept like fundamental changes in our understanding of physics that physicists don't agree with. So
yeah, sorry. Sorry. So yeah, sorry. I still feel like I'm basically not getting it. I don't know. Maybe I'll try like re-listening to the recording or something and see if it makes
maybe
sense.
you're thinking. Are you thinking about fish right now?
No.
Be honest.
No.
That didn't sound very convincing.
I think it sounded very convincing. But
all right,
should
you want to do a fish intermission? You want to
an interfission?
An interfission? Because
Wait, sorry. Wait. When you say intermission, were you imagining that we would then talk more about fine tuning later in the day?
No, it's fine. If you're burnt out, I probably have other things to do as well. If you just want to do the fish stuff, that's fine.
Yeah. What would you think about doing a StreamYard one? I think, you can see the people's face. StreamYard I think it works a little better.
Sure. Let me, yeah, that's fine.
Okay,
then
thanks.
We will talk about. I'll see you shortly. Just send me a StreamYard link.
Okay, sounds good. Yeah, thanks for chatting.
I mean, we're about to chat.
We're just. If we end up with the overall topic, though. Like, did we get to agreement on it, or did we table it? What?
He doesn't. The point of what we're at is that. So it seems like he does understand that there's at least a potential problem with invoking this move in one sense, which is like invoking it in terms of explaining away why isn't there more. But then he tried to invoke it again to say, like, to explain away why there isn't a little bit of it. And he's not. It doesn't seem like he's understanding why a similar parallel response.
Yeah. I think basically where we end is I don't ultimately really get the challenge. Like I'm just confused, you know.
Yeah, I mean, well, you get the challenge. You don't understand how it obtains. Like the challenge is, at least from what I've said so far, is that if we accept this strategy, it results in it's at odds with our understanding of physics. Like that is the challenge. Right. You don't understand how that happens. Is what
that's right. Yes.
Yeah, that's where we are.
Okay.
Yeah.
And is how it happens a matter of understanding a ton of details about physics?
I might not be the best one to ask. So, I mean, I guess you can pull. I don't know.
Because I want the original thing to get resolved. Like, this originally came out of a fine tuning debate, right?
Yeah.
So, like, what does this do for that original dialectic?
Sure. Yeah, it explains rarity of life. Like in any sense. Like it doesn't matter what. Because look, you agree that.
So Matthew put something on the table in the initial discussion, and now we've reached a point that we're not sure if that thing works. Is that correct or is that wrong?
Matthew put an initial thing in the discussion to explain rarity of life, and now what I'm challenging that general move.
And I'm asking,
and it seems like he understands, and it seems like he understands. Yeah, I think where he's at is he understands why the general move is problematic in some areas, but I think he's trying to generate it for another area, and he's not sure why it's problematic in that other area. Like why it results in the same problem.
I'm trying to understand. Okay, wait. And is this the only barrier to the initial fine-tuning debate being resolved, or is there more to that?
Well, the other thing I guess
there's a lot more.
Okay, so just this particular branch, though. So this came off of using this particular rarity reply. And Matthew, is it right to say that you are now currently you're agnostic about whether that reply works?
I would still lean towards thinking it works, but I grant that there's an objection to it that Avi has raised, and I don't know what to say about it on account of not understanding the objection. Though I'd still lean, like, the objection makes sense to me. So, you know, like, sort of pending further reason why it doesn't work, then I would, I think it likely works. But, you know, I'll wait until I, understand it in more detail to be super confident.
Okay. Oh, all right. I guess I don't know. Okay, what do you think about?
I think Omni is like what you listen. I think what Omni is like where you are at, Isaac, when you don't have a lot of food and it's late and you're running low on sleep, and maybe you smoke some weed in the morning. I think that's Matthew right now.
Yeah, I didn't smoke any weed, but just the fish have been sort of taking. It's sort of like not that I've eaten fish, but that the fish. They're on my mind.
So fair enough.
This is why, by the way, this is why I suggested doing the fish thing first, or at least why I thought it, because I knew he would be distracted by this.
I guess I just got confused.
Wait, sorry. To be clear, my fish comment was a joke. The most recent.
I know.
Yeah, sure. Sure. Yeah.
It seemed like it kind of. I wasn't sure if I just missed something, but it just seemed like it petered out without resolution. I'm like, wait, I thought this was all a part of a bigger fine tuning thing, and I want to understand what's going on. And it sounds like we're at a stage where
I've levied an objection. I've levied an objection. He understands what the objection is. He's just not really sure of the way it obtains. Like he's not sure that it obtains. It may be a matter of, and it sounds like he's a little bit burnt out to put in more effort at this point to understand it. He might want to take a break and recharge his battery.
Definitely happy to chat more about this at some future date.
So to be clear, that means that for this whole fine tuning dialectic, the thing to do isn't to go back to the original thing, because we haven't actually reached a point that you're like agnostic.
It would be to continue. It would be to continue about. Yeah, it would be to continue about the legitimacy of the infinite universe though move. as a savior of theories.
Okay, I assume you agree with that, right, Matthew?
Yes, I agree.
Okay, all right, totally. Okay, I understand. Cool.
All right, sounds good. Avi, would you be? Could I send you the StreamYard link in like maybe like 5 or 10 minutes? Would that be okay? Just
Yeah,
taking
5
a
or
very
10 minutes.
brief-
Yeah.
Okay, sounds good. All right, and thanks for listening, everyone. Yeah. All right, nice chatting, and chat soon.